Learn fiber optics with Senko. Welcome to the connected world. Every day, roughly 2.5 quintillion bytes of data, voice, and video are transmitted all over the world, enabling our modern life. In order to transport all of this information, billions of kilometers of fiber are deployed around the world like the artery of global telecommunication networks. This is due to its advantages over copper cables, such as its greater bandwidth, immunity to interference, ability to reach longer distances, overall better reliability, and it is also thinner and lighter. Let's learn more about the optical fiber and how it is made. Basically, an optical fiber is a very thin strand of glass about the same diameter as a strand of hair. Pretty impressive, isn't it? To the naked eye, all optical fibers may look the same. However, that's not the case. There are many different types of optical fibers, each with their own specific application. Some examples are the single-mode fiber, multi-mode fiber, dispersion-shifted single-mode fiber, non-zero dispersion shifted single-mode fiber, and bin-insensitive single-mode fiber. All of them have a similar basic structure, which is a core in the middle and a cladding around it. So how is information being transmitted through something so small and fragile as glass? The fiber core and cladding have different indexes of refraction. This difference keeps the light from escaping the core through a phenomenon called total internal reflection, or TIR. Generally, there are two types of optical fiber, namely the single-mode fiber and the multi-mode fiber. They have different core sizes and index of refraction, which make light behave differently inside of the core. Single-mode fibers and multi-mode fibers can further be broken down to different categories. The single-mode fiber can be categorized under as OS1 and OS2. While both have the same physical dimensions, OS1 fiber has a higher attenuation per kilometer of fiber and is only suitable for indoor use, while OS2 fiber is suitable for indoor and outdoor deployment. There are 5 types of multimode fibers, which are OM1, OM2, OM3, OM4, and the OM5, with OM1 being the oldest standard and OM5 being the latest. They have different core diameter sizes and can commonly be identified based on the standard jacket color defined by various standard bodies. Each type of multimode fiber has a minimum modal bandwidth, with the latest multimode standard OM5 being able to support higher bandwidth transmission for longer distances compared to the earlier standards. Optical fiber starts as a hollow tube of glass. Gases that contain silicon, germanium, and many other chemicals are injected through the rotating tube. The glass tube is then heated by an oxyhydrogen burner that traverses its length. This creates soot deposition on the inner wall of the glass tube. Further heating at higher temperatures during rotation causes it to collapse uniformly, which results in the production of a fiber preform. A fiber preform is a rod of pure glass with a refractive index identical to that of the desired fiber. The fiber preform is then mounted at the top of a pulling tower, which feeds it through a furnace that heats the bottom of the platform until it starts to melt. The melted fiber preform then drops with the help of gravity down to a capstan, where a constant tension can be applied on the optical fiber. As more melted fiber preform is pulled, it is monitored to ensure constant diameter within the acceptable range. An acrylic coating is then applied and cured for added protection and color for identification. The fiber is then coiled onto a fiber spool, ready to be used to manufacture different types of fiber optic cables. Let's have a look at the makeup of a standard optical fiber cord. We start off with a strand of optical fiber with a layer of cladding. The cladding is then oversleeved with an acrylic coating. Aramid yarn is then layered around the assembly to increase the tensile strength of the cord. The whole assembly is then protected with an outer cord jacket that is usually made with polyurethane or PVC. Other than fiber cords, some other fiber cable construction deployed around the world are the slotted core cable, drop cable.
Okay, ladies and gentlemen, we are back with our next session. So our next session will be future services enabled by new optical access network innovations by one reputed professor, Ioannis Tomkos. He is from University of Patras, Greece. So he is the director of the Optical Communications Laboratory at the University of Patras. So I'm welcoming Professor Ioannis. So could you kindly start? Please welcome.
Hello, everyone. I have started sharing my screen. I hope you see the slides.
Yes.
It's a pleasure to be here. I would like to thank the Council for inviting me to give this presentation. I attended the morning session, and I'm very impressed, I have to say, with the developments that are going on in Philippines. I know also what is going on in the rest of Asia-Pacific area region. It's amazing how things are developing and fiber is dominating. But I'm here to talk about the future services that are enabled by future optical access network innovation. And I hope to keep your interest during this presentation. I have been in the industry, optical communications industry, for over 20 years, starting my career at Corning, the company that had invented the low loss fiber that we are all using today. And I will be talking about what is going on currently in the optical access network arena. I have to say that at the university, we're investigating optical fiber technologies, but also how they are used in other networks, like in 5G or even 6G networks. So we have at our campus and our city of Patras deployed all these technologies, and we have essentially a playground where we are examining what are these future technologies and how they can be used to offer all of us interesting applications. So the outline of my talk today is about the evolution of fixed optical access networks. We know about fiber to the building, fiber to the home, fiber to the room is coming up. And of course, we have the convergence of fixed access networks with wireless ones, like the 5G, on the way to 6G in the future. All these are supporting the availability of new services. I would like to talk about those in a minute, way beyond what we can currently get from our fixed and mobile networks. Of course, there is always the issue about the cost of deploying such fiber networks, but there are interesting new technologies and business models that I would like to talk about that can support the reduction of investments or, let's say, can assist in the increased ROI, return on investments, out of those capital that is spent on deployment of such networks. And I would like also to talk about the future technologies that will enable all these exciting new services. Is fiber deployment the end game? Is the home? Or we can think about going further inside our apartment, the room. Is 50G PON the latest technology available commercially? We heard about it just before. The one that will dominate in the future, or we will see even new technologies coming up. All this will be discussed during my talk. We know that we all need broadband connectivity. It can be offered via various means. Of course, fiber access, but wireless as well, even satellite. And we are all used to the old technologies like copper and cable. And all this, let's say, media were operated by operators through different business units in the past. But now all these are converging towards a new infrastructure that offers us a new range of services and opportunities. Essentially, the networks will become bimodal. They are already is, although you are not realizing it. I had before discussions about fixed networks versus wireless networks. Actually, the network is one. It just happens that at the end we need wireless connectivity. The rest of the network, as you see here, is wired, fiber-based. And here is a picture showing the evolution of this fixed access network over the past decade. We started with core technologies, of course, that have advanced and offered us some good rates, like up to 200 megabits per second per user. But then subsequently, fiber technologies have been deployed, reaching our buildings and homes, and in the future, or even inside our apartments to the different rooms. And the technologies that are supporting this fiber deployment are typically based on the so-called passive optical network. And at the moment, the latest standard is the 50G PON that has been already deployed in some areas. So the need for higher bandwidth for all of us, and actually better performance, bandwidth is not just the only measure. There is also latency that needs to be kept low, reliability that needs to be kept high, and all this can be offered better through fixed networks rather than wireless networks. Here we see the evolution of fixed access networks. We started, as I said before, from copper-based installations closer to the home, and now we have gradually the fibers, indicated here with the green color, moving closer and closer to our homes and apartments. And this enables better performance. So certainly fiber gives the fastest speeds and the better experience. On the other hand, we have the 5G networks that offer us connectivity on the move everywhere. And these networks actually have become very fashionable nowadays. Everybody has a 5G phone and a 5G connection. Probably what people don't know is that all these 5G connections are supported through optical fibers. Essentially, every single antenna cell site is connected via an optical fiber connection back to the central office of the operators or the data centers where our content, videos, photos is located. And this convergence of fixed and mobile networks currently enables us to get access to a whole new range of applications, talking about virtual reality, augmented reality, telepresence. All these are applications we have started seeing being deployed. So essentially, both fixed and wireless networks are evolving in parallel over the past decades. But since the emergence of the fifth generation for each one of those, we have seen more and more those two different networks being converging one with the other. And this convergence will be completed with the emergence of the 6G network by the end of this running decade. So the fixed networks now, if we focus on what fiber enable us to do, we know what has happened in the past. We know that we have a very high resolution videos, screens, and also other services that are based on video that we are all like and experience good quality through our fiber connections. But currently, as I said before, we're moving to even a newer generation of services like virtual reality, augmented reality, and all this at home and at our cities. So essentially, with the new fiber technologies and the optical communication technologies that are used to transmit the information over the fibers, we can get even newer services. like enhanced fixed broadband services, allowing more than 1 gigabit per second per user. We can get full fiber connectivity to more and more users at different environments, like not just at home, but also at our business premises, or not just for citizens like us as end users. We can even think big industries using now this connectivity for automating processes within the factories and so on and so forth. And of course, we all care about getting all this bandwidth with lower latencies, much faster, experiencing better quality of service and quality of experience. What is coming up in the future due to the convergence of these networks, the wireless and the wireline, enabled by fiber, as I said, is the so-called Internet of Senses. This is the new trend we will see in the future being discussed more and more, like the metaverse that we are already familiar with. So currently, essentially, if you think about it, we communicate using just two of our senses, sight and sound. But there are more senses available to us. However, we cannot communicate them. With the new networks, indeed, in some years from now, we will be able to experience our environment through all of our senses. So with smart glasses, you can start thinking what can happen, but also with other devices, wearables that can translate languages in real time. We can also have other devices to experience even smell, taste, and textures through haptic technologies or other such new developments. Of course, all this to happen, we need to have fiber closer to our apartments and even inside our buildings. The issue is that all these deployments are very costly. This is because we have to dig and put the fibers in the ground. Of course, there are other approaches like aerial deployment. We have seen that taking place in several countries, micro trenches and micro ducts being deployed to reduce the cost. And of course, the latest trend is the synergy between wireless and wireline networks being deployed together. Because as I said, the 5G network deployment is based on fiber deployment for the backhaul part of the network. Now, certainly, fiber to the home offers the best speeds and better performance, but there are actually many different possible implementations of how to get applications over this fiber infrastructure. The best possible architecture is to have a home run fiber from the central office of the telecom operator all the way to our home to have a single fiber connecting us. But you can imagine that this is very costly. So to reduce the cost in the deployment, we typically use some common fiber leaving from the central office of the operator, going closer to us, and then passive splitters or active switches are separating the traffic to reach every single user. Of course, this means that the total bandwidth available starting from the central office from the operator is being reduced as we are approaching the end users. So we need to find ways to keep increasing the bandwidth, or even though we are sharing essentially all this bandwidth. So besides reducing the cost, as I said, we have to think of ways to improve the performance, and all the different architectures and technologies available to us have their own pros and cons. And we have to carefully think which is the best choice for the deployment we want to make. Different areas have different characteristics, and there is no one solution fits all. We have always to be innovative to find the best solution. But certainly point to multi-point architectures like the PONs, the passive optical networks, using splitters in the field is a very good choice and currently the dominant technology. So at the moment, we have availability of 10G PONs, starting with 10 gigabits per second and splitting the bandwidth gradually. But we are going to move to even higher rates, as you see, beyond 50 gigabits per second, with new technologies that are coming up. And this is a must because we need to support, as I said, not just the fixed users, but also the wireless users that are relying on the fiber infrastructure in the backhaul. Also, in an effort to reduce the cost, we need to remove as many central offices as possible. We need to go to an architecture that is based on central office consolidation. And as we are doing this, performance will improve, cost will go down, and we will all have more affordable connections to the internet. As I said, joint deployments of fixed and wireless networks is an opportunity currently for some countries that have neither one of the two infrastructures being deployed. If we calculate the cost of deployment in a city...
Sorry to interrupt. We have time constraint.
Okay, I'm finishing up. Okay, I'm finishing up. So we can actually use the total cost by joint deployment of 5G and fiber to the home networks. And we can even think about cooperation between operators and system vendors through different business models that we can have available to reduce the total cost while improving the overall performance. So with that, I would like to close my presentation. And if there are any questions, I will be very happy to take them.
Yeah, sure. So so far we didn't receive any questions so far. But I'd like to thank you for the session. So it was really nice, interesting, insightful presentation from you. And I'd like to thank you for your time, even if you are from a different time zone. It really made sense. So hope you enjoyed the show, and you will still be there at the attendee hub and network there and see the other presentations.
Very good. Yes. Thank you so much.
Goodbye.